This is an Algebra 1 lesson about midpoint and distance. We're looking at having 2 points, and what can we find out about the 2 points? So if we have 2 points here, Froggy's hand is on one, and Doggy's hand is on the other. Where's your hand, paw? Doggy's got a paw. There we go. What can I say about the 2 points? Froggy's paw, Froggy's hand, I guess, and Doggy's paw. Well, I can talk about what's right in the middle of them and how far it is, like how far they would have to go to meet the middle. Okay, midpoint and distance. We've got 2 points, 2 things that we can say about them. The first one we'll do is midpoint. The midpoint is the middle point. Who'd have thunk it? Oh my goodness, it's the middle point. The midpoint is the point in the middle. It's the middle point. Oh, but here we're going to say fancy. Let's say fancy. The midpoint of a line segment is the point that is equidistant from the endpoints. So if you have a point, midpoint of a line segment is the point that's equidistant from the midpoints. So you have 2 points. You draw a line between them. It's the middle of the line. Equidistant means that's a fancy way to say in the middle. So let's look at how we can deal with being in the middle. All the different ways we can come up with to be in the middle. Okay, I'm going to start with these 2 points. So I'll have the point here, 3, -2, and the point 8, 6. And I want to know what's in the middle. So again, that will be the midpoint of the line segment that connects them. So I'm going to go ahead and draw the line segment that connects them. Remember, we call it a line if it keeps going, and a line segment if it has endpoints. This one has endpoints right there and right there. Now, somewhere between these is the midpoint, and that's going to be the point that's equidistant between them. Okay, let's just talk for a minute, think for a minute, ponder about what it means to be middle. Let's think about middleness. Okay, well, it's between. I know that much. So we've got between as being middleness. Okay, well, you know, here on the coordinate plane, we have x's and we have y's. We have left and right and up and down. So why don't we talk about it in terms of those 2 components, like where is in the middle, left to right, and where is in the middle, up and down. Okay, let's start with left and right. Okay, the right endpoint is 8, 6, and I'm talking left and right. That's going to be the x-coordinate, and the x-coordinate is 8. And you notice that all along this line, the x-coordinate is 8. It's always 8 here. Okay? Down here on the axis in particular, it's 8. We'll get back to that. Well, here's our other point. And the left to right, again, is going to be the x value. You know, the middle, left to right, ought to be between the 2 blue lines, don't you think? So every place that's right in the middle would be, in the middle. And that's going to come right along in here, halfway. That's halfway between the 2 blue lines. It's 1, 2, 3, 4, 5 and a half. 1, 2, 3, 4, 5 and a half. So that is in the middle. This is in the middle, the midpoint, or not the midpoint, but the middle of the left to right, the x values. So halfway between this x value and halfway between that x value. Okay, and it goes right there. We can do the same thing for up and down. We're talking in general terms here about middleness. Okay, we already got middleness for left to right. Let's try middleness for up and down. Okay, well, up and down, that's going to be the y coordinate. And it'll also be on the y-axis, but I can see that this point, my left one, right there, that's how far down or up it is. Going up and down now. It's at 2. And this one, how far up or down it is right here. It's at y = 6. You know, I'm thinking the pink middle is going to be between these two. What do you think? Middle, between, in the middle? Yes, yes. Okay, so there it is. So what we have here is that, conveniently, this point right here is in the middle left and right, the blue ones, and it's in the middle up and down, the pink ones. Everybody see that? Okay, that's the midpoint, and it's at 2 1/2, and 4. Oops, I'm sorry, 4. 2 1/2, 4. That's where it is. That's the midpoint of the line segment with the 2 endpoints that are given. So it's the point that's in the middle of the 2 points. Okay, now I drew it all out there, but let's write out a little bit what I did. Okay, when I did the blue, that's the X. That's how far left and right. That's what's in the middle, left to right. So what did I do? I said, well, it's between 8 and -3. Middle. Now I've just got two numbers. It's between 8 and -3. Middle. I think we have a word for that. Yes, we do. It's the average. If I'm just talking about numbers, if I'm just talking about 8 and -3, if I want to know what's in the middle of 8 and -3, add them up, divide by 2. What's that going to give me? That'll be 5/2, and that's 2 1/2. Oh my goodness, look, that's it. It's in the middle. This is the left to right in the middle. And it is indeed 2 1/2. That's the X value of my midpoint. Okay, hey, well, I'm cooking with gas. Let's do the up and down. Okay, on the up and down, that was my pink ones. So doing my up and down, let's see. That would be between 2 at the left one to 6 at the right one. Okay, so now I have 2 and 6, and I want to know what's right smack dab in the middle of 2 and 6. Again, average. 2 plus 6 divided by 2. That's 8 divided by 2. And that is 4. Yay! And that is the Y value of the midpoint. So what did I just calculate? I calculated the midpoint whose X value is 2 1/2 and whose Y value is 4. Now, truth, folks, that's the way I do it because I think it's just easier to do it that way. However, there is also a formula, but the formula looks just a whole heck of a lot like this. Let's look at what the formula looks like. Okay, what the formula does is write it out. I'll just write it out for you. Write it out in what we just said here. And what we just said was, how did I get the blue one? Well, what I did was I added them up and divided by 2. So if I have two generic points, you know, and then this is going to be x sub 1, y sub 1, and x sub 2, y sub 2. Why am I doing it this way? I'm doing it this way to show you how it works for everything, not just for this one little pink and blue thing, but no matter if I don't have a pink or a blue. So, what did I do? Here I took my two x's and I averaged them. So what will that look like? That means the x of my midpoint will be x sub 1 plus x sub 2 over 2. In other words, it's the average. The average of the x values is the x value of the midpoint. Okay, what did I do over here? I took my two y values and the y value of my midpoint is going to be the average of the two. So that'll be y sub 1 plus y sub 2 over 2. Okay? So if I want to put it all together and just make it look, well, probably in my mind a little too complicated, but nevertheless we can put it all together and see it. What it would look like is that the midpoint between the 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. Okay, now that's representing just any old points you pick. So the midpoint of any old 2 points that you pick can be written like this. Okay. Again, the average. That's what you do. The average of the x values is the x of the midpoint. The average of the y values is the y of the midpoint. There we go. Okay, so what's that going to look like? Here it is written out all nice and pretty and typed and everything. The midpoint formula. Given 2 points, you can draw a line segment between them, and to find the middle point between them, this would be the way that you do it. Truth, I don't ever think of this. I just average the x's and then I average the y's and I'm done. Okay, if you like formulas, learn it. Be my guest. Okay. Midpoint. Let's work a couple of them to make sure you can work them. Okay, here's the first one. You're going to add the x's. You're going to average the x's. You're going to average the y's to get the midpoint. Okay, so the x value will be 0 plus 8 over 2. That's the average. The y value will be 1 plus 3 over 2, which is 4. So the midpoint of this would then be the point 4, 2. That's the midpoint. Okay. The next one. The x value of the midpoint is the average of the x values. So that of the 2 points. So that'll be 6 plus 4 over 2. Add them up, divide by 2. Or 10 over 2. Or 5. X equals 5. The y value of the midpoint will be the average of the y values. That'll be y equals negative 3 plus a negative 7 over 2. Or y equals negative 10 over 2. Y equals negative 5. So the midpoint between these 2 points would be the point 5, negative 5. Okay, one more. Find the midpoint of these 2 points. The x value of the midpoint is the average of the x values of the points. So that'll be negative 5 plus 1 divided by 2. Add them up and divide by 2, which is negative 4 over 2, which is negative 2. The y values will be the average. The y value of the midpoint will be the average of the y values of the points, or 14 over 2, or 7 over 2. Okay? So the y value is 7 over 2, or 3.5, doesn't matter which one you put. Okay? So we got that. Now, what if you know something different about it? Instead of knowing the 2 points, you know where the midpoint is, and you're trying to figure out where the other point is. So given 2 points, these are the coordinates of the 2 points. You'll see we don't know this y value. Okay? Don't know it. But we do know what the midpoint is. Okay, well, let me think. The x value of the midpoint is the average of the x values of the points. So 2 plus 5 divided by 2 is 3.5. Okay, so that's right. So to do the y value is going to be equal to the y value of the midpoint, 5, is equal to the average of the y values of the 2 points, y plus 3 over 2. Just solve that, second week of algebra, times 2 on both sides. 10 equals y plus 3, y equals 7. So that's your missing value. Okay. Now next up, what if I want to know the distance between the 2 points? So let's look at those same 2 points. See what we can do about distance. You know, the distance formula, I'm about to tell you what it is, but frankly, it's even messier than the midpoint formula, and actually, I never learned it either. And I'll show you both ways, and then you can do it which way you want to do it. Okay, when I look at this, and I see, oh look, there's all these little right angles, and there's these all of these parallel and perpendicular. Look, I could draw a triangle, and I think that's what I'm going to do. I'm going to draw a triangle. So this will be one point of my triangle. Okay. And then this will be the other side of my triangle. Now distance, again, what I want to know for distance is how far is it between that point and that point. You should be saying to me, oh, why are you doing that? What? Draw a line, measure it. Okay, well I could do that, but I'm going to have to estimate. If I do it with inches, it's a big pain. If I do it with, that's just not going to get me exact. Sometimes you just need to know exact, and I want to know the exact distance between these 2 points. And you say, well, then why are you drawing triangles? Oh, because Pythagoras. Since this is all laid out in a nice coordinate plane, I can just count it. What's the length of this side? 1, 2, 3, 4. That's just 4. Okay. What's the length of this side? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So that's 11. Did I do that right? Yeah. Okay. So 8 minus a negative. Oh yeah. Okay. So, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I counted it wrong before. I had it counted at 12 before. That's not right. Okay, so that's 11. We'll go with it here. So, what can I do now? Well, I can say that the distance that I want, D, is like the hypotenuse of this right triangle. Okay. So I'll have a squared plus b squared equals c squared. Oh my goodness, the sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. Oh my goodness, it seems like I've heard that somewhere before. I hope you've heard it somewhere before and you've said it like a dozen times to make sure you really know it. The sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. The sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. We're going to call it D this time because it's for distance, and so why not? Okay, so the sum of the squares, 11 squared plus 4 squared equals C squared. And since we're calling it distance, I'll just go ahead and write D for it. Okay, this is 121 plus 16 equals D squared. That's 137 equals D squared. And I'm thinking that's probably prime. Yeah, I'll come back if it's not. So to do it, we then have that the square root is equal to, the distance is equal to the square root of 137. Okay, now to be able to do that, we need to remember simplify that. We need to know if there are any happy couples or lonely onlys in there. It will not divide by 2. It will not divide by 3. How do I know that? How do I know that? Somebody tell me. Okay. Lucy, thank you. Okay. Lucy told me that she knows it will not divide by 3 because if you add it together, 1 plus 3 plus 7 is 11, and 11 won't divide by 3, so it won't. It won't divide by 5. It won't divide by 7. It won't divide by 11. I don't think it'll divide by 13 either. So, nah. That's prime. So that's as simple as we can get it. Remember, with radicals, this is the simplified version. If you're asked to turn it into a decimal, then you do. That's not simplified. The right word for that is approximated, not simplified. So if we were to do this one, we'd put in the square root. Can you see that? Can you read that? Okay, you just put in. I'll just put it in. And it's approximately 11.7. So it just depends on what you're asked for. Sometimes you'll need to have the exact answer and sometimes the approximated answer. So again, the square root is exact and this is approximate. Yeah. All right, next thing up is the formula itself, which is just the Pythagorean theorem. And you look how messy that is. That's why I never use it. Because it would be more convenient if you wanted to type it into the graphing calculator. But I always punch something wrong pushing that much in. But you can do it. Remember, if you're going to put it into the graphing calculator, to use the parentheses appropriately. What is this? Look, that's just what we just did. Finding the x value, the distance between them, the length of that side, the length of my blue side, and what was I doing there? Okay, so all this is the x sub 2. So that's just finding this distance. We did 8 minus a negative 3 to get 11. That's what that is. Here to find the difference in the y's, that's all we did. I did 6 minus 2 to get 4, or I just counted it to get it. Really, it's easier, you just count it. Okay, but that's the way to do it. If you're not drawing yourself a triangle, you can subtract the 2 and get it. So this y is how you get the 4. This x's is how you get the 11 here. And it works for everything. Then you'll recall that in the Pythagorean theorem, this was squared. I just square rooted both sides to make it isolate the d. Again, I do it by counting it. I just draw it and count it. But either way is just fine. It'll work just fine. Okay, some examples of distance here. Okay. Want to know the distance between these 2 points. Okay, well, that's going to be subtract. And leave the formula. Before you're going to subtract to find it, I'll work it the messy way for you. So to make sure you can do it. Okay, you can just draw it and count it, and frankly, that's what I vote for. I find it the easiest. But using the formula is also a handy thing, so you need to be able to do it. So, the difference of the x's, so that'll be 5 minus 0 squared plus, and the difference of the y's, 1 minus 3 squared. And it didn't matter which one you picked to be 0.1 and 0.2. You'll get the same thing either way. It doesn't matter. And then when you're done with that, you're going to square root the whole thing. So this will be 5 squared plus a negative 2 quantity squared, and then all square rooted. So that'll be the square root of 25 plus 4, or the square root of 29. 29 is prime, so that is the simplified version. That is the final version. Let's look at these two. Now this one's kind of weird. Yeah, let's look what happens when we do this. Okay, we're going to take the difference of the x's. That'll be 5 minus 8 squared plus the difference of the y's. So that's negative 9 minus a negative 9. Put all of these negatives in here because you're going to do it in your head. That's where you're going to make your mistake, because that is a plus. This will be negative 3 squared. That's negative 9 plus 9, which is 0. And 0 squared is, of course, just 0. The whole thing, again, is in square root. So now we're left with the square root of 9 plus 0, which, of course, is the square root of 9, which is 3. You say, wow, that one's a whole number. That's really unusual. And really, it is pretty unusual. Because dealing with the Pythagorean theorem, You're going to have a lot of irrational numbers. Well, let's look at why that's the case. Okay, so if we graphed this, it would look something like this. You'd have the point 5, negative 9, say right there. And here, 8, negative 9, say someplace over here. Oh, look. It's just a horizontal line. Try to draw a triangle with that. No, no, no. And really, what do you have to do? You didn't really, if you noticed ahead of time that those were the same, all you had to do was count 5, 6, 7, 8, 3. 1, 2, 3, 3, and you're done. So you really didn't have to do all of that. So anytime you notice that both the x's are the same or both the y's are the same, it's just the distance between the other two, like this. Okay. Next one's up. Y'all do these. Do these, pause it and do them, and I'll put the answers up. Okay, here's the answers. Hopefully you're getting it. Notice here I checked using my short division that I round up with a prime number. I was trying to just make sure that it was prime. Okay. Okay. So what if you have a circumstance like this? You know one of the points and you know the distance, but you don't know everything about the other point. And you're trying to figure out what that value is to make it right. Well, let's look at see how that works. So again, we've got the formula here. The distance is 5. So I'll put in 5 equals, and it's going to be the square root of all that stuff. The difference of the x's, 3 minus 0, quantity squared, and the difference of the y's. Okay. I'll simplify that. Oh, wait, we've just been doing radicals. This radical expression is isolated on the right-hand side of the equation. There's not one on the other side. How do I solve it? I square both sides. So that'll be 25 equals 9 plus 1 minus x squared. And then this 1 minus x squared, we've got to expand that out because, and remember, it is 1 minus x times 1 minus x. I have to multiply it out. And FOIL or just multiply it or whichever way you're going to do it. So this will then be 1 minus 2x plus x squared. That's what that'll be when you do it. Okay? When I multiply it out, I'll copy the rest of it around it. 9 plus 1 is 10, so I'll just rewrite this as 10, oh, excuse me, as x squared minus 2x plus 10. Why did I do that? Well, I wrote it in descending order, remember, by the degree of the term. And notice that this has a squared on it. This is a quadratic. Remember, to solve a quadratic, what do you have to do? You have to make it equal to 0 and then probably factor it. So to make it equal to 0, I'll subtract 25 from both sides. Now look at that, say, can I factor that? Can I factor that? I can factor. AC, 1 times negative 5. AC goes on top. B goes on the bottom for B, which is negative 2. So now I need what two numbers will multiply to give me negative 15 and will add to give me 2. Well, you go through all the factors and you figure out that it's 3 and negative 5. So I'll take those two, and this will be plus 3x minus 5x, which is what I'm going to write, instead of negative 2x. I'll copy everything around it, and then I'll factor by grouping. This will be x times x plus 3 minus 5 times x plus 3. That is a plus because it's minus a minus. I factor out my outside ones, x minus 5 times x plus 3. What will I get from there? Okay, that way I know that either x minus 5 equals 0 or x plus 3 equals 0. So that would be either x equals 5 or x equals negative 3. Both of these work. If you substitute it back in here, you're going to get the same thing. If you put in 1 minus 5, that'll be 4 squared is 16. If you put negative 3 minus, 1 minus a negative 3, that'll be positive 4 squared, which is 16. It works either way. You say, well, how can that be? How can they both be the same? Well, funny you should ask. I'll show you. Here's how it would work. If you were graphing this, this is actually 2 different points. So, you have your 1 point, which is 3, 1, 3, 1. That's this point. And then somewhere where x equals 0, that would be here. Well, look. That's 5 units, and that's 5 units, but both of them are when x equals 0. This 5 units puts it down at negative 3, and this one is up at 5, and those are the 2 answers. I probably should have used y. Okay? Yeah. Okay, an example here. Here we've got an example. Okay? A rescue helicopter and an ambulance are both traveling from the dispatch center to the scene of an accident. The distance between through the grid lines is 1 mile. Find the route that the ambulance traveled and how many times greater was it than the one that it was actually the direct route. Okay, this is an ambulance that's going on city blocks. It can't go straight. It can't just fly unless it's a helicopter ambulance, in which case that would be a good thing to do. So what do we have here? Okay, we can use the distance formula between the 2 points, or we can see this as a triangle and count it. For counting it, we actually do need to count it either way. So the distance along the red route is 10 and 10. 5 and 5 for a total of 10. So the route by the red route on the streets. So on the streets would be 5 plus 5 over is 10 miles. Okay. If it were a helicopter ambulance and it could fly directly on the blue line, how much less would that be? Okay, well, we can Pythagorean it. Oh, I remember the sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. Oh, wow. Okay, well, this is pretty easy. It's 5 squared plus 5 squared equals c squared. So that would be 25 plus 25 is 50 equals c squared. So the distance is the square root of 50. Okay, well, let's simplify that, because remember, sometimes you need to know the exact amount. This one you really don't need to, but let's make sure we can remember how to do it. Find the prime factors. That'll divide by 2. That'll divide by 5. Remember, divide only by prime numbers until you get all the way down to 1. And then whatever you've divided by are your prime factors. So we'll have a happy couple of 5s. Go out on the town, and a lonely 2, stay home and pop popcorn and watch Netflix. So the exact distance is 5 times the square root of 2 miles. However, we're talking about miles. We don't usually say square root of 2. So it would probably be best to approximate it, and it's approximately 7 miles when you find that, put it in the calculator. So the question was, how much further is it to go on the streets than it is to be the helicopter? Well, the distance is 3. It's 3 longer. Okay, 3 miles longer. So, and here endeth the lesson.